Okay, now this one we continue from the section 2.7 of the complex number. Okay, but this topic in this section we gonna learn about roots of complex number, how to get the root of complex number. I will explain in the for the square root and cube roots. Okay, so we just start for the example for the square root. Find the square root of complex number. See the example, you go to the page 21, example 16. Okay, you can see for that, but I will give you some different way to do. But now we go according your handout first. Okay, example 16, find the square root of 2i. Okay, so in 2i, right, you see this 2i. If we rewrite this one in the complex pattern or the Cartesian form, right? This one C gonna be equal to what? If only this one, okay. So C equal to 0 plus 2i, right? That means x equal to 0 and y equal to 2i. Okay, but now we want to find square root of this one. So in this case, the square root of 2i means we have z square equal to 2i. Okay, equal to 2i. So, but we know from the polar form, right? Z equal to R. We can write the full writing R cosine theta, right? Plus I sine theta. Okay, so then we can combine with the De Morey, right? You have to study the De Morey theorem first before you take a look this one. Okay, that way you will confuse why come from, what's going on. So then right now we want to find square root, right? So we just have from the formula of the De Morey. Okay, go back this one. De Morey formula of De Morey is what? If you have z power n, right, will equal to Rn, and okay, full writing, okay, becomes cosine n theta and plus I sine n theta. This is a full writing of the formula of De Morey. Or this one you can write at the short term. This one the short pattern become Rn cis n theta. Okay, so now we can apply from the De Morey theorem to this question also, because we want to find square root of this complex number, square root of 2i. So from this one, come back to this question. So if we have, then we have z power 2. R gonna be from the formula, okay, De Morey, so become R power 2 also, correct? And then cosine this n, right? N, because n equal to 2 now, so become 2 theta plus I sine 2 theta. Okay, this we apply from the De Morey theorems. Okay, and at the same time we know z square equal to equal to 2i, right? Equal to I, which is we can write in this pattern, correct? Take the common 2 out, 0 plus I, correct? Because when you time in, this becomes 0 and this one 2i, still the same value, correct? We did not change anything, the value of this complex. From this one, we can apply that r square. Then you can see r square equal to 2, right? Identity. So from this one, r gonna be what? Plus minus square root 2, right? But the r is a radian, so we don't take the negative. So we're gonna have square root 2. Take only the positive values. Okay. So from this r equal to 2 here, see that? r equal to 2 here. So, and then x equal to 0 and y equal to 1. Okay, so this is z squared. Okay, now we know from this r square, give the identity r square equal to 2 here. So then on one r gonna be plus minus square root 2, but the r the radians. So this tan or radian should be positive. We don't use the negative side. Okay, now after this, when we get r, and then from here, from this one, right, identity, so we can get this one equal to this, and psi to theta equal to I. So then from this equation, so we will get cosine to theta equal to 0. At the same time, by all sine to theta equal to 1. So you can work either one to get the theta, right? So if we work from the cosine to theta equal to 0, see what we have. To theta equal to r cosine 0 is what? Cosine 0 is 90 degrees, right? The quadrant 2, correct? So gonna have this one equal to pi over 2. Because 90 degree quadrant, okay, quadrant 1, I mean. 90 degrees, just exactly on the like this one. Like this one. Okay, 90 degrees. So this is theta. So cosine become at over hypotenuse. So that because they're close to this one. Okay, so we have become 0. That's mean pi over 2. So we get this one pi 2. And then when you have pi over 2, right, when you rotate it, gonna be what? This next one gonna be 2 pi, right? Okay. So then the next rotation gonna be pi over 2 plus 2 pi, right? Okay. So this one gonna be what? 4, 2, 2, 1 become 5 over 2 pi. Become 5 over 2 pi. Oh, cannot lay down. So next, you keep rotate, correct? So then next one gonna be 5 over 2 pi. 5 over 2 pi plus another 2 pi, right? So this one gonna be 4, become 9 over 4. Oh, sorry, 9 over 2 pi. Okay. So from this, then we want only one theta, right? So equal to what? 2 dy, right? So divide this one. So become pi over 4. And this one 2 divide this term, right? So become 5 over 4 pi. And at the same time, this one 9 over 2 pi divided by 2 theta, gonna be 9 over 4 pi. So we can stop right here because you see if you from this one, where I come back, I delete this one. If I plot this graph, okay, this one. So this one we have theta equal to pi over 4 here. Okay, this is the first quadrant here. So theta is a pi over 4 here. Okay, so and when you rotate this one for the next one, gonna be 5 over 4 pi. That means 5 over 4 pi equal to how many degree? 5 over 4 times 180. Times 180. So 5 over 4 times 180. So this one become 4, 4, 16, 4, 5, 20. So 5, 5, 25. So 225 degree. That means if you rotate, the next rotation gonna be on third quadrant. This is gonna be just the opposite like this. Okay, so from here to here is a 225 degree or 5 over 4 pi. okay, or 5 over 4 pi. And then this theta is this angle is what? Going to be pi over 4, right? This one is a pi over 4. This one's a pi over 4. So that means you lead this value, right? Okay. So then if you rotate again for the next rotation, they will drop in here again, and you go again, they will drop in this terminal arm again. So they keep repeating. So we just take only the first two theta is enough, because 1/9 over 4 pi, they will drop in the same arm here. And if you go the next rotation, they will drop in this one again and rotate same this one and repeat. So we get the first theta only. So after this, so we can find the root, okay? Because we want to find the 2 square root of this one. So just say if theta equal to pi over 4 here, theta equal to pi over 4 here. So from this one, we can find the C1, for example, the root, the first root gonna be what? You can, now after this one, you just replace in this formula. Okay, the polar form, replace in the polar form formula. Okay, so R we have this one, right? So become square root 2, and this one gonna be cosine pi over 4, and plus I sine pi over 4, and then you simplify. Okay, then you simplify this one. So root 2 is what? Cosine pi over 4 is a 45. Cosine 45 is a 1 over root 2, right? So we get 1 over root 2 plus I sine 45 also 1 over root 2. Okay, then you simplify. This one expand it. So this time become 1 plus I. So the first root Z1 equal to 1 plus I. Okay, so at the same time, then you can find this one. When theta, the second one, right? So if we use this color, maybe. The second one, if theta equal to this one, 5 over 4 pi. If equal to 5 over 4 pi. Okay, so then you can have the root C2, right, subscript 2, gonna be root 2, the same thing, and then this cosine 5 over 4 pi, 5 over pi, plus I sine 5 over 4 pi. And then just simplify, do the same way. Then you're gonna get the second root. Okay, so 5 over 4 pi is 270 degrees. So is this one gonna be 2, right? Square root 2. But 5 over 4 pi is a 225 degree. The drop in the third quadrant. So cosine. So you leave cosine pi over 4, right? But this third quadrant cosine is what? Minus. Sine minus cosine minus tangent plus. So this one gonna be minus or negative 1 over root 2. And then this one also drop in the third quadrant, this become minus, right? So have what? 1 over root 2 I. Then you simplify. This one gonna be time it up, become minus 1 minus I. So then we got this one is the root, the second root equal to negative 1 minus I here. So this is the answer, the square root. So that means must have the two roots, final roots, right? Got the answer here. So these are two answers here, and this one. Okay, for this question. This one we use a trigonometry, okay? But then I will give you the next one for the formula. I will use the formula, okay? Formula, I need more space. Okay, I go to the next page to use a shortcut, okay? I will provide you the shortcut way, which is doesn't have in this handout, but I give you this one. Go next page. In the same question, okay? Use file, we have in the same question, but we're gonna find by use shortcut. So we have this one, z square equal to 2i. From previous example, I write down here. So this one, when z square 2i here, right? If z square, this one gonna be r square, correct? Same like the last question, okay? Plus 2i. Plus 2 theta, I mean. If z square, because this one can imply that z equal to r cosine theta plus I sine theta. Okay, so this is going to be 2 theta plus I theta. For this one, I may not use this one. I like the formula first, then we know how to do. Okay, the formula of this one, we have z k subscript k equal to in the shortcut, okay? Root r here. N, and then the whole thing cosine theta plus 2. This one like a rotate 2k pi over n. Okay, and then plus I sine theta plus 2k pi over n. And then close. This is the whole thing here close. So this is a formula. This is a shortcut. If we have like a C set or complex, find the square root. Okay, this is a formula. Find the root of the complex. To say that can use for any square root, cube root, fourth or fifth and sixth root. Okay, so we go back to this question, this example, the old one here. If square root of the square root of find the square root of 2i. Okay, that means z square equal to 2i. How to use the formula? In this case, if for k, like for example, you have square root like this. If the square root is a square root, okay. When we're gonna start from k equal to 0 and 1, it cube, like the cube, right? The cube root. So k gonna be equal to 0, 1, 2, right? It fourth root. So k gonna be 0, 1, 2, 3. So we start k equal to 0 when you rotate and go on until when you have the n root. Okay, so that means k gonna be what? 0, 1, 2, and so on until k minus 1. K minus 1 because we start from 0, so k minus 1, right? Until k minus 1. Okay, now how to use this formula? Okay, how to use this formula? Then when you use formula, I think maybe easier than the previous, but still okay because previous example we use trigonometry, but now we use a formula to the shortcut. So in this case, this one, right? When you have this one, the z square here is similar to, I can write in this way, correct, everyone? Or I can write 2 outside. This one, maybe we let this one first. I can have like this way. This one mean I can write 2 out, right? Like a previous example. So 0 plus I. Because when the time in, that's equal, correct? So in this case, in this case, we know right away R is what? R is a 2, this one. This is a position of R, right? And then X is what? 0. Y equal to 1. Okay. So then we're gonna use rotate for the first one, K equal to 2. Because this is a power 2, so we start from K equal to 0 and 1, that's all. So we get the 2 roots. Okay, but before that, we have to get the zeta first, right? How to find the zeta? Find the zeta. So you can, we can plot graph like this way. You can leave from here because x is here, right? So go up high is I here. So this means like we have very small triangle here. You use the unit circle method, okay? So we can have this one. So when you lead, this is theta here. So when you lead cosine theta is what? Of over hypotenuse, this become 1, right? Okay. So let's see. Yeah, because this is x and then go up y, right? Go up y, so 1 here. So cosine at over hypotenuse, so 0. So theta equal to what? Equal to 1, this is what? Pi over 2, 90 degree, right? So we get the theta equal to pi over 2, 90 degree. So then you replace theta in here, in the formula. So now we go to see if, now we start to use formula here. May I use this one? Write down this is a formula. This is a formula, okay. And okay, then we know where it is. Now we start to use formula. So if k, the first one, if k equals to 0, okay. So then n we know is a 2, correct? Square root. Because when square root is 2, we don't need to write 2 here, right? Everyone, okay. So I erase this one. Usually we don't write the number 2 on the square root here. So r equal to 2, correct? R equal to 2. And then formula cosine. Then theta is pi over 2. And plus 1 plus k is a 0. And then times pi. Okay, and this is the whole thing here. Divided by n equal to 2. And then plus I sine, the same thing, right? So pi over 2 plus 2 times 0, k0, okay, times pi. And this whole thing also divided by 2. Now close the big bracket. Now after this you simplify. So we have this one is what? Square root 2. And this one, you see this 2 times 0 pi, the whole thing 0, correct? So we left pi over 2, so we got cosine pi over 4. And then plus I sine should be same, right? So pi over 4. Okay, now you can simplify. So root 2 Same thing like period one. So you just simplify. I leave you pi cosine pi over 4, so 45 degree is what? First quadrant 1 over 2. And this one pi, right? So same thing, plus 1 over 2 I. So final we have 1 plus I. Okay, when next you get the when k equal to 1. Okay, because we start this one because it's square root, right? This one. So you get k equal to 0 here and k to 1, next one here. So from this one, do the same way. Okay, so you're going to have square root 2. And this one close cosine and the big bracket here. So become theta of pi over 2. Then plus now 2 times k less than or equal to 1. So like 1 here. And then pi. And the whole thing over 2. The whole thing over 2. Okay, and then plus I sine. So this one gonna be pi plus 2 times 1 pi because k equal to 1. This one pi over 2, sorry. Okay, and then this whole thing is divided by 2. Close the big bracket. Okay, now you just simplify like now. So become root 2, and this one become what, 2 pi, right? So 2 become 5 over 2 pi. 5 over 2 pi divide 2 become 5 over. So cosine become 5 over 4 pi. And plus this side the same, become I sine. This is I, okay? Become I sine. Same thing, 5 over 4 pi. You see that the same value with the previous one, right? When we use trigonometry. And then they let you simplify. For final gonna be what? -1 minus I. Okay. So now this is the answer. So we got the same answer, right? If you use the formula. And this formula is faster, correct? So when you do test or exam, if question did not request any method, you can use any one. You can use trigonometry. We just finished all this formula. Okay, so this formula is a popular one. It's a popular. You can apply for any root, square root, cube root, fourth root, up to n roots. Okay, so apply by that way. But when you read theta, you have to read from just the direct from the question. Like this one, I give example here. Hot graph, right? And then read for theta. Okay. So this one shorter than we do the trigonometry one. Okay, so not too hard, right? Okay, now take a look, come down and study step by step because I explained very slowly already. Now one more, I have one more shortcut, the formula. Okay, the shortcut formula. If maybe get this one. Another one, okay. And let down here. Got this, then see this one, okay. If I use maybe the color green, okay. So I have another formula, the shortcut for the square root only, okay. This one for the square root only, square root. So the formula is x plus yi equal to this I, okay, equal to plus minus and the whole thing square root r plus x over 2. The square root just go along power 2, okay, and plus square root x. This is r, okay, this is r. This r. So r plus x also over 2, but this term is a I. Okay, this is a X, this is a Y. And then next one, same thing. If you are Z, right? Like this question. See this question. Okay, see this one is a plus, right? So you use this formula, the middle gonna be plus here. Okay, but if in the font of Y become negative sign, for example, you say write down here. For example, say equal Z equal to any number, maybe say 2 minus 3i like this. If minus here, then this middle one gonna be minus. This one gonna be minus. Okay, so that means this formula can be plus and minus here. So when gonna be, if plus here, you use plus, if minus, you use minus here. So that's all. That's a formula of square root 2, the square root. Okay, so this one can use only the square root. Okay, cannot use for another root. But this formula can apply to any root there are, up to n root. Okay, then this one, come back to this question, how to do, if for example, if I use from the same example here. Okay, so because this one is what we have x plus 2i, right? X plus 2i. So r we got already equal to 2, x equal to 0, and y equal to 1. So you're gonna have, we use the x plus yi, correct? X is 0 plus I, correct? So then you just replace here plus minus. So I is a 2, so like square root. I is a 2 plus x minus 0, okay? Divided by 2. Because this question, the value of I or imaginary term, the value is a plus, so we use plus sign here. Because this one plus, right? So we plus sign here. And then square root, I is a 2, x is 0 over 2, and I outside here. Then what we have final? This one become 2 root, so this one equal to what? Plus minus what? Let me rewrite here, okay? So this one become 1, correct? 2 cos square root 1, so still 1. And plus this one also 1, correct? So we have 1i. So now you see we have same answer, right? This one means 2 and 2 root mean 1 plus I. Another one become minus 1 minus I. So the same thing, correct? Okay, so this formula for square root only, don't forget. Okay, but this one can apply for any root. Okay, so this is about find the root of the complex. So when you use cube root, do the same way. Okay, so when you use the cube root, do the same way, like a power 3. So this power 3 and then this do the same way. So if power the set, for example, if set power 3 here, that means must have 3 answer, 3 roots unity. Okay, okay, so have same 3 roots. Then if you use formula, right, you're gonna use this one root cube here. So you start k 0 and go on, k equal to 1, k equal to 2, do the same way as this one. Okay, and then you look, simplify and get the answer. But if cube root here, okay, cannot use for this one, okay, again, this is a square root only. That's all. If fourth root, do the same way, keep rotate. You find theta first, find r from this one. The similar like this one idea. Okay, so I will skip the example for cube root, but you can study by yourself from your handout, okay? They have from the cube root on the page 23, right? Page 23. So you can study from there. Okay, they do the same way, exact same. Okay, but I will explain another way by using algebra, find the root of the complex. Okay, so now see this one, the next page. If we use find the root of complex, do the same way, okay? If the same example, okay? And set, say set power to complex, the square root, right? Equal to 2i here. But I will use by algebra, which is another way, okay? So from this one, again, we can apply that set complex equal to x plus y. This one even much easier. Okay, so from this one, you can say if I have z square, so I power 2 for both sides, right? Power 2 for both sides. So this one gonna be x plus yi, and then power 2. So this one you expand it. Okay, become x squared plus 2xyi, and then plus y square I square, right? Okay, so then the z square, this one equal to what? Equal to this one, right? So I can write down here is equal to 2i. Okay, from this one I will have 2i equal to this one. Then we simplify this one, become x squared plus 2xyi. Okay, and then I square equal to -1, right? So you replace, become minus y square, right? Now you rewrite it down, rewrite it to, because we want to use the identity and get the coefficient equal. So x square and y square I can write together here. Plus 2xyi, right? So equal to 2i. Okay. So 2i, this one I can write down at the front as it's a 0, correct? That means x equal to 0, right? We know already from previous example. So in this case, you can get identity. This part, x squared, you can say 0 equal to x squared minus y squared. And this one, 2 equal to 2xy. So we got it here now, what we have, 1 equal to xy. So then you use these two equations. You can use elimination. This is how to be equation 1 and this equation 2, right? So you solve for xy. When you got xy, you replace back here, then that's the root you want to get. Okay, or maybe we try this one, how to work it on. So if you have this one, y equal to 1 over x, right? Now you replace, substitute y equal to 1 over x into where? Into equation 1. So become x squared minus 1 over x power 2, right? Equal to 0. Okay, this one substitute, okay. Substitute this one into 1. Okay, so this y replace in there, y replace in here. Okay, so this one gonna be x power 4, right? And minus 1, correct, equal to 0. So then this you can factor now, right? Become x squared minus 1 and x squared plus 1 equal to 0. But this one can expand, can factorize more, correct? Become x minus 1 and x plus 1 equal, not yet, so x squared plus 1. So from this three brackets, right, we got what? We got x equal to 1 minus 1, or this one become what? This bracket, right? X squared plus 1 equal to 0. So we have x squared equal to -1. Then x equal to what? Plus minus square root -1. But square root -1 is I, right? So we have plus minus I. So another well, the value of root or value of x is going to be I and negative I. So we have 4 answer this one, but then after that we have to answer the root, right? You have to, then you go back to find the root. Okay, so you can replace x. When x equal to 1, what y gonna be? You can put like that. You can leave it in here, up to you. Okay, and then if x equal to negative 1, replace here, right? And y, replace back here, maybe easier here. Now, see this one. Okay, so we, okay, finish this question, I think. So now we try to get the root. If x equal to 1 here, right? First one, then y gonna be what? Y is a 1. Okay, if x equal to negative 1, okay, so y gonna be negative 1, right? So y equal to x negative 1, so y equal to negative 1. Yes, the x is negative 1, so y negative 1. And say if x equal to I, so this one y gonna be 1 over I, right? Then I, you have to simplify every time if denominator in the term of I. So you just conjugate like this time I top and the bottom. So the top gonna be I and the bottom gonna be I square. But I square equal to negative 1, correct? Here. So become negative I. Okay. So then next, if I equal to negative I here, this one, last one. So y gonna be 1 over negative I, and then do again conjugate, eliminate, try to change I to be any number. So time I top and the bottom. So we have I, and this minus, right? Minus I square. Again, I square equal to negative 1. So negative times negative become plus. So this equal to I. So now you can write in this the pattern here. Okay. So the first set, what we have, if x is a 1, y is a 1. So we have this one. And then the second root, if x is a negative 1, y is a negative 1. Okay. And third root is what? If x is I, y is a negative I also. Okay. So y is a negative I. So negative I times here. Okay, y is a negative I. So this one become this is I, okay? So become I minus I square. But I square equal to negative 1, negative become plus. So we have I plus 1. Okay, and then fourth, what's gonna be? When this is one, my last one, replace in here, okay? So if I negative, x negative I, so y is a I times I. Then now we replace all of this one, right? In here. The final what we have here, replace in. So this one I, y is a I, right? And x a negative I. So we have negative I plus I square. So this one negative I, I square equal to negative 1. So we have negative I, negative 1. So they're the same, right? You see that? Same, right? So that means the two root answers are only this one. And this one just repeat, right? When you rotate in the, when you rotate, like the first one we know is a pi over 4, right? And then you rotate again, gonna be here. Okay, when you rotate, they're going to get this arm again and rotate, gonna be this arm again. So there are only two root from there to here. this one and this one. So that's, you can see this is the same, and this is the same as this one. So final answers are only final answer. So just say this one, right? This is a two root. Same, right? Same answer with the period. So this one I provide you for all the method. You can do by this one is algebra and formula, right? Formula, that's a square. If for square root you can use the formula square root or use the CK, that one. Okay. But don't forget this one can use all, but the period, this one you can use this formula. Okay, then this all the way, all the how many? 3, 1, 2, 3, 4, 3 to 5 ways to find the roots of the complex number. Okay, that's the idea I give to you. Then you take a look by yourself in the handout, right? You can see more example for the square root, like on the page 22, and the cube root is on the page 23, like this. You take a look. The same idea how to do, exactly same, okay? And on the page 24, they have example over there. So you can take a look, and then if you want to use formula and you try, see the equal answer or not. Okay, all the page, this one, they have more example. So you can study by yourself, get the idea I have to you now, this one. Okay, so then this is the idea of the find the root of complex number. Then this one you can do, you can practice question also, okay? You can practice question on the exercise 2F. I will write down in GC. Maybe practice only 3 to 4 questions only, okay? I will write down, and then you try to do it. I already give you answer key there, and you can check your answer. Okay, I think that's all, and then we're gonna leave the last section 2.8. Okay, see you, bye.